Welcome back to the lecture on machine learning. One of this week's topics is going to be decision trees. Let's dive right in. Have you ever played the 20 questions game? If you have, well then you're actually somewhat familiar already with the concept of decision trees and how they work. If you have not, then here's how it goes. You think of some kind of concept, let's say an animal, and your friend gets to ask you questions. And these should only be of the type where you have only yes and no as the possible answers. Your friend does this for a while and eventually figures out you were thinking about a dog. Now in machine learning, we want to build these decision trees based on data and then do classification. So let's look at a dataset. Right here, we have a dataset X with two features, X1 and X2, and some class labels Z, which you can see as the color of the individual points in the image. So we have three classes here, red, green, and blue. And our goal is classification of unseen new data points, which is a very common task in machine learning. It means that based on the data that we have, we want to find some kind of model that tells us for unseen points, so for example, a point right here or right here, what class that point is likely to belong to. If our model does this well, then we say that it generalizes. Well, if we look at our dataset, we can approach classification of new unseen points intuitively by dividing up the space that we have into regions where one of the classes dominates. So it looks like down here we have a rectangular region where there's only blue points. The same holds for that piece right here and over here. And we can continue that until we have divided up our whole feature space. So let's do that real quick. Now to classify a new point, like the one right here, what we do is we figure out which region it belongs to, and then look at the majority class in that region. So for the point right here, since it's in a sea of blue, it would be classified as blue. Note that we use rectangular regions because these can be described fairly easily. What I just did by hand can be formalized into a decision tree. So for the rectangles that I just drew on the previous slide, a decision tree would look like this right here. Now note that we don't specify each region separately, but we do it in a hierarchical way. So at each node, we split the space that we have in half. For example, at the root right here, we split our space into half like this. Not necessarily half in terms of the number of points, but into two pieces. And we continue to do this hierarchically until we have a whole region specified that mostly contains one class. So this leaf node right here specifies the upper blue area. So let's look at this a little bit more formally. In a decision tree, we have nodes, like this one right here, and each node corresponds to a feature test and leads to decision boundaries like we've seen before. So right here, we would split on the second feature, and the value we would split at is 3.9. This feature test can have two outcomes, true and false. And this corresponds to the two branches for the preceding feature test. If we have reached a leaf node, that leaf node defines a region in the input space and also a distribution of the samples in that region. Remember that since we only ever split on one feature each, we create cuboid regions, and that's because our splits are always axis parallel. Now, if you want to classify some new data point X, what we do is we test all its attributes according to the tree that we have, find the region that contains the point, and get the final class distribution in the leaf node. If we, in general, want to calculate the probability of a point in the region R being classified as belonging to the class C, then we just take the number of points in that region for class C and divide it by all the points in that region. Since the data point X should be classified as the class that is most common in that region, we have to take the arc maximum over all the probabilities for all the classes that we have. And this is then the label for X. Let's go back to our example. Let's say we want to classify the point 8.5, 3.5, which is seen as a star right here. Then we would start at the root node, and 3.5 is larger than 3. So we move down here. 8.5 is also larger than 7.8. So we move down here. And since the second feature is smaller than 3.9, we end up in this region down here. We can see that it has 4 red samples, and since that's the majority class, we classify the point as red. And you can also see that in the image above, that it's clearly in a red region. The tree that we looked at for our data example is just one possible tree for this data set. So the question is, how would the perfect decision tree look like? And we've already talked a little bit about that. We would like our decision tree to generalize to new data. Well, we just have one data set, and we're probably not going to have new data coming in. So we just simulate new data. And we do this by taking a whole data set and splitting it into a training set that we use to build the tree from, and a test set that we use to assess how well our model works and how well it can classify new points. This is done by just computing the labels for the test set and then comparing them to the true labels. By this, we get an accuracy score of how many labels are correctly predicted. The question that remains is, how do we build such decision trees? And that's what we're going to look at next.